and about meteorology. That's something that I'm interested the most. I will show some measurements that we do in Spitsbergen. So let me first introduce myself. I'm polar researcher. I can say about myself that I'm a climatologist and hydrologist. I'm employed at the Institute of Geophysics, Polish Academy of Sciences in the Department of Polar Research and Marine Research. I'm responsible for meteorological observations and database from Polish Polar Station Hornsund in Spitsbergen. I took part in many expeditions. One of them was overwintering in Hornsund. That means 13 months at once at the station in the Arctic, where I worked as a meteorologist. What I would like to show you today are some questions that I answered. First is, what are the meteorological phenomena? The other one is, what's the difference between weather and climate? The other one is, why meteorology is important. And at the end, I'll show you where and how we do the observations of meteorological phenomena in Spitsbergen. So we have different jobs. One of them is chemist. A chemist is a person that studies chemicals. A psychologist studies psychology. Glaciologists study glaciers. A hydrologist studies hydrology. Do you have any ideas what can meteorologist do? What he does? Maybe you can write the answer in the chat on the right upper panel. Measure the temperature, the weather, the moisture. He studies weather and climate, the atmosphere, atmospheric pressure, meteorology. Yeah, but does a meteorologist study meteors? There is another good answer. How much rain falls? Meteors? The answer is no. Any other answers? No. No. Okay, so let me show you. That's partly truth, because meteorologists do not study flaming rocks flying through space. These are meteors from space or comets, and that's not the topic for meteorologists. Although you were not right, because the answer is yes. Meteorology is the interdisciplinary scientific study of the atmosphere, and meteorologists study weather meteors. And those meteors in meteorology are atmospheric phenomena observed in the atmosphere or on the surface of the Earth. So, answer is yes, but not those comets, not meteors as we think nowadays about, not the rocks that fall from the sky. So, if we know what is the study for meteorologists, I want to show you 4 groups of mentioned meteors. So there are hydrometeors, lithometeors, photometeors, and electrometeors. I guess that most of you could give answer what are these. So I'll just show you some examples. What are hydrometeors? Hydrometeors are bits of liquid or solid water in the atmosphere. So when we have some small particles of water in solid or fluid form, liquid form, we can say about hydrometeors. An example can be fog. Other examples, all the precipitation, so clouds and rain and snow and different kinds of precipitation are composed of hydrometeors. So we can say that those are also hydrometeors. So we know different examples of hydrometeors. For example, snow. Snow and rain are, of course, the most popular hydrometeors. Other type of meteors. Oh, yeah, sure. I can change slides slowly. Would you like me to go somewhere like back a few slides before this one? No, it's okay. Sure. Sorry, I'll try to slow down a little bit. Other type of meteors are lithometeors. And these are a mass of dry particles suspended in the atmosphere. Example of that is dust whirlwind, for example. So when we have dust and sand in the atmosphere, that's aeolian processes. So those particles move in the atmosphere, and we can say that in the atmosphere there are lithometeors. Dust whirlwind, we can see them in the dry areas or when there is drought. Dust storm, that's an example of dust storm in the Arctic, but there are huge sandstorms or desert storms in the desert areas, in the tropics. Here it was also dry and the wind was really strong, so it was moving those small particles in the air. Another group of meteors is photometeors. So the bright objects or phenomena that appear in Earth's atmosphere when sunlight or moonlight create a reflection. An example is halo. We can see halo around sun or moon when we have specific clouds, the layer of high clouds, cirrostratus. So these are particles of solid water because it's really high, up to 10 to 12 kilometers above us. And when there is sun or moon behind those particles, behind these ice particles, we can see halo. I guess many of you have seen it. It's the ring around sun or moon, as seen on this picture. Another example is parhelion. It's on sides of the sun. It appears as in similar way as halo. The other name of parhelion is sundog, but I don't think it's official name, sundog. In meteorology, we usually use parhelion. Another example of photometeor is, of course, rainbow. So when we can see that sun is shining to rain, we can see rainbow appears. Another example of rainbow is white rainbow. It appears on fog. When it's foggy and there is sun above, sometimes we can see white rainbow. Another example of white rainbow Another group of meteors, electrometeors. Those are visible or audible manifestation of atmospheric electricity. So examples are lightning strikes and also auroras. Here is example of aurora above Polish Polar Station in Spitsbergen. And people are really impressed by those phenomenon of auroras. They appear in the exosphere, so for about 100 kilometers above the Earth's surface, especially in polar regions. It happens when natural light, that's the natural light that's displayed in the sky, and it's produced by collision between electrically charged particles from the sun that enter the Earth's atmosphere. So when we have solar wind and it disturbs the magnetosphere, ions start to move, different ions in the atmosphere, for example, oxygen. So this aforementioned ionization is excitation of atmospheric constituents, as I mentioned, for example, oxygen, that emit light of varying color and complexity. So you can see green auroras, gray auroras, violet auroras, even red ones, depending on the constituents of the exosphere. So, meteorology, we know what is it about. So we should think about the weather. What's the difference between weather and the climate? The weather is something that we have behind our windows. When you look through the window, you can see the weather. It can be sunny, it can be cloudy, it can be rainy. But the weather is the state of the atmosphere at a particular time. So now we have weather like this when you see through the window. But if you do the observations of the weather for longer periods, actually, by definition, longer than 30 years, then you can say that you can assess the average weather. You have statistics, you have means, you have maxima, for example, maximum annual temperature, minimum annual temperature. Then you can say that you can know the climate. And climate, by definition, is the average weather in a place over many years. So the difference is in time period between those two. Meteorology is concerned with the current state of the atmosphere at given time and place. So meteorology deals with the weather. And you mentioned that meteorologists deal also with the climate, but actually climatologists deal with the climatology. So climatologists are interested in long-term average weather conditions and trends for a given location. So when you have data from at least 30 years, you can study the climate of this place and you can become a climatologist. When you do observations every day, you're interested in changes of the weather. And of course, meteorology is about changes. The atmosphere changes really fast, but when we can see some trends in those changes after many years, we can say about climate. And that's the main difference. So climatology can be like reading of history book, because we have data from previous years, at least 30, as I mentioned. And meteorology is more like reading a news article. So when you have newspaper, it's, you know, about today, about tomorrow, but it's not about previous 30 years, and that's something that climatologists deal with. Climate system consists of 5 major components. It's the atmosphere, hydrosphere, atmosphere, so, you know, the air. Hydrosphere is water. Cryosphere is water in the solid state, so glaciers, for example. Other climate system components are land surface and the biosphere. And as a system, there are many connections between all those spheres. The climate system is continually changing due to interactions between these components. The atmosphere is the most unstable and rapidly changing part of the Earth's system. So when you think about those components, biosphere, land surface, cryosphere, hydrosphere, and the atmosphere is changing the fastest. Here are components of climate system. I guess you have those charts in your handbooks. So I won't go into details into that because, as you can see, it's really complicated, all those connections between different spheres. So in the atmosphere, we have clouds, we have precipitation. In the ocean, we have water, sea ice. There is, of course, soil in the air, different land cover, for example, forests. And that's something that influences the climate. The question is meteorology important? What do you think? Maybe you can answer in the chat. I will wait a minute or so for your answers. Is it important or not? And why? On this picture, we can see Warsaw a few days ago during snowstorm. So you can see what happened. One of the answers is meteorology is important to predict weather, bad weather especially. Yes, it is important. Another answer. Our everyday life depends on the weather, of course, because every day you have to choose what to put on you, what clothes do you need to prevent cold or warmth, in order to program our schedule, of course, and life. So, for example, our schedule, when we plan a weekend to go somewhere during the weekend, we would like to know the weather. Yeah, in USA, people know when to run. Yeah, and that's something that's also important, to give people the information if there will be some hazardous weather. All right, so we all agreed that the meteorology is important. You all said that it's important because weather and climate are natural resources and hazards. These are resources of warmth or rain, water, and they can support but also can pose a threat to life. So when you have to run from tornado, you know that weather can be hazardous. And of course, there is also a threat for property and the environment in the weather. So nearly all areas of human activity are weather, climate, and water sensitive. And I guess all of you will agree with that. Fluctuations of weather and climate influence, for example, food production, agriculture. Of course, when to plant crops, yeah, all the agriculture stuff that has to be done throughout the year. When to plant all different kinds of plants, so for example, potatoes and stuff, depends on the weather and, of course, climate. Transport is also, weather also influences transport, construction, energy, tourism, and many other types of business. I mentioned transport. I showed you the picture of the cars in the snowstorm, but there's also aviation and shipping, which is really highly vulnerable to wind and storm conditions. And that's why all airports have own weather stations. But not only airports. There is web of meteorological stations around the world, just to give people information about the weather and climate. So what's the job of meteorologists? They acquire, process, and interpret data from instruments on land, at sea, in the sky, and in space, because there are, of course, antennas in the space, satellites. And those are used for weather forecasting, so the predictions of weather in the near future or far future. It's also important for climate monitoring and the provision of meteo services and products. So, as I mentioned, there are weather stations, and the weather station is a facility. It can be on land or sea, where there is meteorological equipment, all the instruments that measure atmospheric conditions. Here is a picture taken in Hornsund, in Spitsbergen. That's how the meteorological site looks like. So, meteorological site is the place where those instruments are set, and the meteo site has to be representative for the region. So it cannot be on the cliff, on the slope, or just below the mountain. Here, maybe it's not proper picture, but you have to believe me that there are a few kilometers to the mountain behind this meteo site. The size of the meteorological site has to be at least 15 times 15 meters, and it has to be located away from any major obstacles like huge rocks or huge buildings. As I mentioned, Svalbard in the far north, that's where our station is located, and actually not only ours from my institute, but also many others. Svalbard is archipelago, so many islands are called archipelago, and this archipelago is located between 77 and 81 north. Its area is 62,000 square kilometers, and the biggest island is Spitsbergen. The land is covered by glaciers in 60%. Mountains, of which the highest is Newton-Toppen, 1,717 meters, and lowlands between those mountains. The population is around 3,000 people throughout the year, because during summer there are many tourists that come, so this number multiples. Here you can see the picture taken from the space. You can see the clouds, but between the clouds there is Svalbard archipelago. Our station, Hornsund, is located in the southern part of the biggest island of Svalbard archipelago, the biggest island, Spitsbergen. I don't know where you live, but I'm giving this presentation from Warsaw. And distance from Warsaw to our station in Hornsund is 2,771 kilometers. The distance to the nearest big city, to Tromsø in Norway, is 800 kilometers. And it's really close to the North Pole, some 1,450 kilometers. So in the high Arctic. The station is located on the northern shore of Hornsund Fjord. These are pictures of the fjord. And that's how the station looks like during spring, when there is lots of snow. And here you can see the difference in the end of summer and in springtime. So most of the snow disappears. There's only some snow on glaciers and high up in the on the mountains. Some information. Yeah, I mentioned about the web of meteorological stations. They are part of World Meteorological Organization. Our station is takes part in it since 1978. Yeah, it has been working since 1978. And all the data collected at the station is sent to Oslo, Norway, automatically in every hour. And observers, there are two observers, two meteorologists working at this station. And they do the observations and they send their observations in every 3 hours. So they work in 24-hour shifts. And they send those observations as numerical codes. So there are different numbers for different types of weather. For example, there is number for rain, there is other number for snow. And when you have this formula of numbers, you send the temperature, atmospheric pressure, and stuff like that, and the present weather as synop to Oslo. And there is a key code. So when you will see this kind of number, reading the code, you can see what's inside this synop. And those synops are used to create weather forecasts and are transmitted to international exchange of meteo data. And then computers using those synops, they use models, different climate models, to predict the future weather. What kind of meteorological parameters we measure in Hornsund? Here is the list. Air temperature, air humidity, wind speed, wind direction, atmospheric pressure, precipitation, ground temperatures, total sunshine, and there are also observations of cloud cover. So how much sky is covered by clouds and what kind of clouds, at what levels. Visibility, so how far you can see the objects around you. We also measure in Hornsund snow cover. We also observe different weather phenomena and also check the sea ice cover. Having the data since 1978, we can say that the mean annual air temperature in this period in Hornsund is -4 degrees. Maximum was noted in 2015 and it was +15.6 degrees, so not that bad during summer, but as the maximum. Usual weather during summer, the air temperature during summer is around +5 degrees. The minimum was recorded in 1981 and it was -35.9 centigrades. There are around 250 days with snow cover during the year in Hornsund, and maximum wind speed noted, recorded, was 176 kilometers per hour. Now I would like to show you how this can look, the hazardous weather when the wind speed is really strong. That's during the day in the springtime. I recorded that not far from the station. It was some 15 or 20 meters. As you can see, strong wind was blowing snow, so the visibility was really bad. And that's how the weather can be hazardous. I mentioned about observations of the clouds. So here is the example of orographic clouds recorded. Orographic clouds appear above the mountains when the air mass is moving through the mountains and the air is uplifted. And it gets colder and the clouds appear. So we can see this fan effect above mountains. That's also something pretty interesting and something that is observed and noted by meteorologists. I mentioned about meteorological site. There we have many different instruments, for example, thermometers, barometers, hygrometers, radiometers, and anemometers. Thermometers measure air temperature, barometers atmospheric pressure, hygrometers humidity, radiometers UV radiation and different kinds of radiation. Anemometers measure the wind speed and direction. This is how they look. Anemometers in Hornsund are on the top of the meteorological mast. So they measure the speed and direction of wind. There are also rain gauges, pluviometers. They measure precipitation. In Hornsund we have different kinds of rain gauges. It's because we have strong winds there, and when it's snowy, we have different data from those different instruments, and it's really interesting to compare this data. What is measured actually when we have different instruments? Heliographs, those are kind of prismats that measure total sunshine. And also radiometers measure the sunshine and UV radiation. Sensors are placed inside special case. It's called Stevenson screen. Yeah, so when you measure the air temperature, humidity, you want to put it inside the white case because it prevents the direct solar radiation that could warm the instrument. And there, it's open. The air can flow and blow through this instrument, through this case, but it's covered from precipitation and direct solar radiation. At meteorological station in Hornsund, we sometimes have guests. For example, these ones, polar bears. We are really happy to see them, but not always. Polar bears are under protection, so you cannot do anything to them, but they try. They are really intelligent animals, and they are really interested in anything what they can see, what, in their opinion, doesn't suit the landscape. So when they see some instruments, or in this case barrels, they try to smell it, they try to open it. Yeah, and they are really interested in everything what they can see. So sometimes we lose instruments to the wildlife. Yeah, that's tired polar bear after his work. This one came pretty close to the station, tried to open the window. There are also other animals that, so when the polar bears appear, we try to frighten them. So we use signal pistols, we shout, so they should run and not destroy our instruments. And that's what we do. We have to keep an eye on the instruments that we have. So as a meteorologist, you observe the atmosphere, but also the instruments that are set. For example, reindeers, what they do, they can bite cables. It also happens, so you keep an eye on reindeers as well. Foxes, they also like cables, so we have problems with bitten cables by Arctic foxes in Spitsbergen. Throughout the years, we observe I mentioned about the climate. We observe in Svalbard and actually through the whole world warming, called global warming. In Svalbard, you can see the average annual temperatures in the beginning of 20th century used to be around -8. Now it's -4. and this has really big implications on the landscape. Here is the location of Hornsund Station, and you can see Hornsund Fjord, which is 40 kilometers long. The yellow line in the middle shows the extent of glaciers in the beginning of the 20th century, when it was much colder than it is now. So when it's warmer, glaciers retreat, they melt. We have different instruments in different parts of the fjord. So on this picture, taken from the top of Hornsundtind, the highest mountain in this area, you can see the extent of the glaciers in the beginning of the 20th century. They were there, and now they moved back to the right. For example, Horn Glacier moved 14 kilometers. Samarinbren moved 10 kilometers, moved back. Peierlbren, 8 kilometers. So glaciers depend on the weather, depend on the climate, and these are the biggest implications of the climate that we can see there in Spitsbergen and in the Arctic. Warmer weather, warmer climate means less ice and less snow, so retreat of the glaciers. If you're interested in measurements done at Hornsund Station, you can Google this site. It's hornsundigf.edu.pl weather. There you can find meteorological bulletins that we write. These are reports produced once a month. Yeah. So, for those of you interested, I invite you to check this website. Thank you for your attention. Now I think is the time for any questions that you may have. How the white rainbow forms. Yeah, as I mentioned, it appears on the particles of fog or mist. It's the same as regular rainbow when there is sun, but there is reflection of the sun on the particles of fog, and that's how the white rainbow forms. Any other questions? The most interesting phenomenon I experienced, that's also a question, meteo experience. I think for me the most impressive are changes of weather in the Arctic because they happen so quickly. For example, you can think that the weather is pretty good, so you don't need any jacket. You just take your sweater and trousers. But even after a few minutes, you can have so much change. It can appear so quickly. For example, clouds and snow. Yeah, even during sunny day, you have to be prepared for those changes. So your equipment should be inside your backpack, or you just put many layers of your clothes. And it's really impressive to see clouds coming really fast. It's really impressive to see all the atmospheric phenomenon. For example, auroras are really impressive. So something that is I wish you to see. Right. I guess that some of you are finishing the lesson, so I'll say goodbye and thank you for your attention. I hope it was interesting for you, and hope to see you during my next lessons. Actually, in a few days I'm going to New Zealand, so I think I'll bring some fresh pictures from there. A lesson from New Zealand? Actually, I'll be at the conference, so I won't find any time to give lecture. But I have presentation there. Thank you. Right, so take care. Be aware of the weather. Now you know what it is, and hope some of you will be interested in that and become meteorologists in the future. It's really interesting to be meteorologist or climatologist. Thank you. Bye.